transformation of function. Let's consider the graph of f of x equal to x, g of x equal to x plus 2, and h of x equal to x minus 3. We will go ahead and graph this three linear function on the same xy coordinate plane. So we start with making the table value. And we will graph each of this according to the color that we have. So here we have the graph of each of the linear equation. Note that all of these lines are parallel with each other. Let's see the difference between the red line and the green line. Let's say the green line is for f of x, the original function. The g of x is the red line. Note that here that we added 2 in this equation, right? So if you take a look at the distance between each of this point, this distance is 2. This means the graph is moved up 2 units. Okay. Whereas in the next question, we have 2x minus 3. Well, compare the graph of the green line and the blue line. The difference here is 3 units. From each point to the other is 3 units. And it's going down. So here is 2 units. And it's going up compared to the original graph. So for the vertical shifting, suppose that c is greater than 0, the graph of f of x plus c is shift the graph of y equal f of x, c unit up. Okay, and c unit down if we subtracting. So let's take a look at the next case. We want to graph x squared, x plus 2 squared, and x minus 2 squared on the same coordinate plane. So first we make the table value. So with the calculation, we complete the table value. So now let's go ahead and plot this value on the xy coordinate and take a look at the graph of each function. So here we have the first graph is f of x. And let's start with the second graph. And so we have the second graph. Note that with plotting the value that on the table only give us half of the graph. This graph, the right hand side. And look at this part of the graph. However, because this is the graph of a parabola, we can use symmetric to get the other side of the graph as well, which is the left part of the graph. And let's go ahead and plot the last graph. And here's the graph of h of x. Using the table value, we only get the left half of h of x. And use the symmetric, we get the right half of h of x. So we complete 3 graphs on the same coordinate plane. Now note that between the graph of f of x and g of x. Every point on the graph of f of x being shifted to the left by 2 units to get the graph of g of x. And compare the graph of f of x and h of x. Every point on the graph of f of x being shifted to the right 2 units to get the graph of h of x. So when you add into the variable, you shift in the graph to the left, whereas when you subtract in, you shift the graph to the right by that many units. Explain how the graph of f of x obtained from the graph of f of x. Explain how the graph of g of x obtained from the graph of f of x. Then sketch the graph of g of x. So note that here we subtract c unit, we subtract c unit here. This means g of x is shifted down 1 unit compared to f of x. And the next part here, the two things that are different. Here we add 2. So then g of x is shifted to the left 2 units compared to f of x. Okay, so let's start with the graph of f of x. F of x is the absolute value function. So the graph of f of x is given by this. So this is the graph of f of x. Now we take the graph of f of x, we shift it down 1 unit and to the left by 2 units. So the way we shift it is, we take the vertex, we move it down 1 unit, and we move it over 2 units. Take this down 1 unit, move over 2 units, and connect it to graph. So this is g of x. In the next problem, here we move up 3 unit and to the left 1 unit. Compared to the graph of f of x. Okay. F of x is a square root function, so the square root function looks like this. Okay, so here's f of x. And to get the graph of g of x, we take the vertex, we move up 3 units, 1, 2, 3, and we shift to the left 1 unit. Take the next point, move up 3, and to the left 1. Take the next point, move up 3, to the left 1. So here we get the graph of g of x. sketch the graph of the following on the xy plane. So again, I make the table of value and we'll plot the graph. Note that when we take square root of -9, we get the value undefined, so there is no value here. Here and here. Similarly, this is why the reason we don't have any value over here and here. Okay, so let's go ahead and plot the graph on the xy coordinate plane. So this is f of x plus g of x. Note that g of x is the reflection of f of x about the x-axis. Okay. And so I guess you can make a guess that each of x is the reflection of f of x about the y-axis. So let's plot it to see. So here each of x. So each of x is a reflection of f of x about the y-axis. So where you place the negative sign makes the difference. If you place the negative sign outside, means you add in a negative sign to the function itself, then the graph is reflected about the x-axis. And if you add a negative on a variable, then you reflect it about the y-axis.